Unit 6, Lesson 8, Special Right Triangles. There are certain special angles where it is possible to give the exact value of sine and cosine. These frequently seen angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So in case you haven't recognized these already, these are the special right triangles that we dealt with in the last unit. We dealt with it a little bit at the end, and now it's going to come into play a little bit more. So take a look at the triangles here. We have our 30, 60, and across from the 30 we have a side value of 1. Across from the 60 we have a side value of radical 3, and across from the 90 degrees we have, for the hypotenuse, 2. So if you can recall, we have this ratio. So opposite the 30 degree is a value, in this case it's 1. Opposite the 60 degree is whatever that value is opposite the 30 times the radical 3. And then opposite the 90 degree, which is the hypotenuse, is whatever is across from the 30 degree angle times 2. As for the 45, 45, 90, we have two side measures that are the same, and then across from the 90 degree angle, the hypotenuse is whatever the length of that leg is times the radical 2. So we're going to use the values of these ratios in the special right triangles in order to find our sine and cosine function. So sine of 0 degrees is 0. Sine of 30 degrees is opposite over hypotenuse. So the opposite is 1 over the hypotenuse of 2. For the 45 degree, the opposite is 1 over the hypotenuse of a radical 2. We can't have the radical in the denominator, so we must rationalize it. And we get a radical 2 all over 2, because the square root of 2 times the square root of 2 is the square root of 4. That's a perfect square. That simplifies to 2. So that goes in the box right here. The sine of 60, if we look at the angle 60 over here, that's opposite radical 3 over the hypotenuse of 2. And then the sine of 90 we've already located or found in the previous lessons as 1. Cosine of 0 degrees is 1. Cosine of 30 degrees, that's this angle here, is the adjacent radical 3 over the hypotenuse of 2. Cosine of 45 is the adjacent of 1 over the hypotenuse of a radical 2. We're going to have to rationalize the denominator, and we get the same value as radical 2 over 2. Cosine of 60 is the adjacent side of 1 over the hypotenuse of 2. So now it says to find two values in the table that are the same. As you can see, sine of 30 is equal to the sine of 60 degrees. We have the sine of 45 is equal to the cosine of 45. And we also have the cosine of 30 equal to the sine of 60, but they only asked us to find two. So what do you notice about the angle measures? That their sum is equal to 90 degrees. Find a different set of values in the table that are the same. Well, we can see that sine of 0 and cosine of 0 have two different values. And what we notice about their angle measures is that they are the same. So the moral of the story is that when the angle measures are the same, the sine and cosine functions will not have the same values. But if their angle measures have a sum of 90 degrees, then they will have the same exact values. Okay, so the ratio of sides of special right triangles, we already delved into this before, so we can just fill in. We've got the length of the sides that are across from the 30-degree angle, so that was given here as 2. And then to find the side that's across from the 60-degree angle, we just multiply radical 3 to the 2, and then we double 2 in order to get the length of the hypotenuse. I'm going to do the same for the rest. So in this case, we're given 3. The side across from the 60-degree angle is 3 radical 3, and then we're going to double the 3 in order to get the length of the hypotenuse. So this becomes 4 radical 3. We're going to double the 4 and get 8. So the pattern goes as this. It doesn't matter what value is in across from the 30-degree angle, but whatever it is, we take it and multiply radical 3 to it to get the side opposite the 60-degree angle, and the side that's opposite the 90-degree angle, hence the hypotenuse, we're going to double the side that's across from the 30. So for the 45, 45, 90, we have the two sides that are the same, but we take the length of that side and multiply by radical 2 in order to get the hypotenuse. Same goes for all the rest of these. So we have the same value here, and then it's 3 radical 2. Same value here, then it's 4 radical 2. Same value here, then it's that value times a radical 2. Okay, example 1. Find the exact value of the missing side lengths in the given triangle. So as you can see, we have two side lengths that are the same. They are the legs. And if that's the case, then the two angle measures must be the same. So the only angle measures that they can be are 45, 45. So that means I can use the special right triangle application, and I have the lengths of two sides. They're both the same. So in order to find the side that's opposite the 90 degree, thus the hypotenuse, is 6 radical 2. The exact value of the missing side lengths in the given triangle, I need to find that. So I have the side that's across from the 90 degree, that's the hypotenuse. I need to find the side that's across from the 30, that's where I like to start, and then I'll be able to fill in what B is. So we know that the hypotenuse is double the side that's opposite the 30. So we know that to be equal to 3. If I go ahead and solve this by dividing out the 2, I get A is equal to 1.5. That's 3 halves. Then I'm able to find B, which is take that value, 1.5, and multiply a radical 3 to it. Just set up an equation based on the ratios of the sides of the special right triangles, and you'll be able to solve for the missing values. So examples 3, they want us to find the exact value of the missing side lengths in this given triangle. So we're given the length that's opposite the 60-degree angle, and we know the relationship that that has is that it's the side that's opposite the 30-degree angle times a radical 3. So we're just going to solve this equation for A. We can't have a denominator with a radical, so we are going to rationalize it. So we get 3 radical 3 all over 3. Those cancel out, and I just get radical 3. So this is radical 3. And C is just take what that value for A is, radical 3, and multiply a 2 to it. Okay, so we're going to find the exact value of the missing sides using special right triangles, just an extension of what we were doing. So I see the two tick marks indicating that we have equal sides. So that means this is also the same thing, and then the length of the hypotenuse is that times a radical 2. So here I'm given the length of the hypotenuse, and I need to find these two values which are the same. So we know that x times the radical 2 is equal to the hypotenuse. I'm just going to solve this equation by dividing out a radical 2, rationalize the denominator, and get x is equal to 8 radical 2 divided by 2, and we know that 2 divides into 8 4 times. So my value for x is 4 radical 2. In this case, I have the side that's across from the 30-degree angle, which makes life easy. So I know I can take that value, multiply by a radical 3 for the side that's opposite the 60 degree, and the length of the hypotenuse is 8 times 2, which is 16. Okay, I have the length that's opposite the 60-degree angle, so we know that whatever's across from the 30 degree times a radical 3 is equal to that side opposite the 60. So I'm going to solve this equation by dividing out a radical 3. I can't have that in the denominator, so must rationalize. We get 4 radical 3 all over 3. And then we take that and multiply by 2 in order to get the hypotenuse. So it's 8 radical 3 all over 3. That concludes this lesson, so please have the associated homework completed.